Hi, my name is Deborah Armstrong. I'm from Mineola, Texas, and I teach at Mineola High School. And this summer, I got the opportunity to work with the Penn State College of Engineering, Architectural Engineering. And we were studying human collaboration with robotics on the work site. So basically, if you've ever seen the episode of I Love Lucy, where the chocolate's flying by and she's trying to eat it as quick as she can to try to keep up, it's a funny scene, but at the same time, it actually can be dangerous. So imagine large blocks or other things flying by that fast. Now we have some issues, and more in the industry, we're getting more and more robotics. So from this slide, you can see that tying rebar, welding, laying bricks is all now part of the robotic process. So the challenge is how do we make the as safe as possible? So first, they need to be able to read when is the human person actually feeling a great deal of stress. So the question is how can we measure stress? They looked at cortisol levels, heart rate, and they came up with brain waves, EEG, being the best method to figure out if they are feeling stress. And if they are, then we needed to slow the robot down. If they're not, keep it at the same speed, or if they're even very, very low, maybe we can even speed it up and be a little more productive. So from that, they came up with an idea of, well, they all have to wear a helmet anyway. So you could actually put the EEG, the sensors, and they use 32 sensors to read all of those waves coming in. And they had lots and lots of data coming in. So whenever the data came in, it had to be filtered because EEG can pick up every time they blink, it picked up something. Loud noises, it would pick up. So they had to filter all of that, try to get the data down to the most important. And then that data was sent through a process where it can actually be analyzed, and they call it the prediction equation. And then from there, it's sent to the robot, and then the robot would respond accordingly. And it was 84% accurate. And so from down here, you can see the data analysis, and that's basically what they, and I got the chance to actually look through. And now the best part for me is I wasn't able to do the EEG. So the lab actually sent me the Vernier Data Quest and a bunch of different sensors. So I was able to perform my own experiment here in Texas. And you can see from the heart rate, we had a resting heart rate, and then I had a low exertion heart rate, and then I had a high heart rate. And I had that connected to a Lego robotics kit, and the robot was able to respond based on these rates. The next thing I'm excited, and you can see right here, that's the robot I connected it to, and there's the programming that I use. And then from here, what I want to do is be able to continue the research and look at different vital signs such as respiration, blood pressure, and all that sort of thing. I'd like to thank CSATs and definitely thank the Architectural Engineering Group. Thank you.